They're not like, you know, the gross cockroaches that we don't like, you know, kind of thing. These are outdoor cockroaches. The most that might happen is they might fly into your house because they might be attracted to a light, but they definitely don't want to take up residence. And only the males have wings, so you don't have to worry about females coming in and laying eggs. But the wings are a lot duskier looking. So our standard house cockroach looks really greasy looking. These look really dusky looking. And these are the good ones. These are our friendly roaches, or at least they're our friendly native roaches. And the cool story about them that I think is really cool is the adaptation that they have to living in a humid environment. And that is that they can absorb humidity from the air. So, but if we live in a real like dry environment, you know, the humidity couldn't possibly be high enough for them to absorb humidity from the air. But that's why they burrow down under the sand. Because just like when you stick your finger in the sand at the beach, the deeper you go, the wetter it gets. The same thing happens when you're anywhere. The deeper you go, the more moisture there is in the soil. And they dig until they get to an area in which the relative humidity of the cavity that they're in is relatively high. And then they avert these weirdo glands that you see here that are basically dehumidifiers. They actually pull the water out of the atmosphere, which is a really neat adaptation to, you know, a dry environment. We see tons of examples of that with plants, but this is a classic one for insects. So here's something, again, a trail story. You won't necessarily see cicadas, but you're going to hear cicadas when you're out on the trail. And I don't know if the audio is set up here, but we'll give it a try and see what happens. Ooh, no, the buzz isn't them. They in the background. You got bad speaker, I think. But you've heard it before. It's the noise that you hear, particularly when it's hot outside. Okay, they like to call when it's hot. And there are a lot of host plant affiliation that they have. So this species here, Mariposa, is associated with oak trees. The species that you see here, Rubrovinosa, is associated with manzanita. The species that you see here, Nigridarius, is associated with chamise. So they have these tight host plant associations. And the immature stage of them lives under the ground, and it feeds on the roots of those plants. And it's only when they come out in the summertime, typically, or the late spring and summertime, that we hear them calling. And those are the males calling, so the females don't sing, and the males are calling for females. There is a level of territoriality here, so they mark territories with their acoustic singing. And the way in which they make the noise is kind of neat. I don't know if we've got any people in here who can jelly or vegetables or stuff like that, but you know, there's the lids that you put on your top of your ball jar. You know how when you take them off, or actually after you've pulled them out of the hot water, they make that satisfying noise, pop, as they've sealed up, and then when you release the seal, they pop back up. Well, the noise-making device on a cicada is much like that lid. Okay, so they've got a little lid inside of their abdomen. I think it's in their abdomen, it might be in their thorax. I can't remember which way it faces. And there's a muscle attached to the middle of that lid, and they can pull that lid back, and then they let it go, and it goes. Except it does it at such a high rate that it's, you know, instead of. So. Cool little critters, you can hear them, and there are resources online if you want to learn your cicadas by sound, just like you learn your birds. There are resources online for some of our species around here, not all of them. We do have 21 different species in San Diego. We don't really hear about them as much as you would if you lived on the East Coast, because on the East Coast they've got those 13 and 17-year cicadas that come out in huge mass numbers, and they serve cicada tacos and all that sort of stuff. Ours don't come out in those regular periods. Instead, they're constantly coming out. Okay, so year after year after year, they're coming out. They probably still have a really long lifespan underneath the ground, but there's no synchrony in the way in which they all emerge. So they just come out every other year.
What's the reason for the noise? Is it mating?
It's males trying to attract females. Yeah, definitely. And so I don't have a photograph of it here, but over in the desert, we have a species that is black on one side and it's white on the underside. And it is because it's kind of this early bird gets the worm kind of thing. So the males want to start calling as soon as the sun comes up, right? Because you have more opportunity. So the first one to get hot enough to call, because their metabolism has to come up. So when the sun comes up in the morning, they face their black side to the sun so that they can get hot as fast as possible. But in the desert, you have to worry about this thing called critical thermal maximum, which means baking to death. And so once you get too hot, then they can turn around and they can face their white side towards the sun that has higher reflectance. There's also a sweating cicada, which is really cool. There's a cicada that actually has pores in which it releases some of its body fluid. We don't normally think of insects as sweating, but there is one cicada that's been demonstrated in. You guys have these here, don't you? Anyone? Yep. These are harlequin bugs, harlequin stink bugs. We find them on the plant formerly known as Isomerus, bladderpods, the non-fancy name for them. And so these are stink bugs, and the cool story with this particular stink bug is that stink bugs, as the name suggests, should stink. Okay, but these don't stink, not in the way stink bugs traditionally stink. So if you were to grab like a green stink bug, like your garden variety green stink bug, and you held it in your fingers and harassed it enough, it would eventually ooze out this stuff from its glands of its torso that stink, all right? These guys you handle all you want and they will not release anything like that. They might pee on you or something like that, but they're not going to release this scent gland system. And that is because they have taken another different evolutionary route, okay, of instead of having these scented defensive compounds, they are taking all of their defensive compounds and they're storing them inside their body. And they're getting those defensive compounds from this bladderpod plant. If you ever picked a leaf of that up and crushed it between your fingers, it stinks really, really bad. I think it stinks really, really bad. And there's very few insects that like to eat that plant because all that stinkiness are toxic chemicals. Well, this species has figured out, evolved over time, to be able to store those chemicals within its body. And just like probably the more popular story that you're aware of, the monarch butterfly that eats the toxic milkweeds, that makes them kind of unappetizing to vertebrate predators. So what have we noticed about this? It's very similar to monarch butterflies. Brightly colored, and not only brightly colored, but very similar colors. It's red and black and white, okay? And generally, red and black or orange and black and white in nature means stop, okay? It means either I'm really distasteful or I'm possibly going to hurt you by stinging you, okay? And so this is what we call convergent evolution, towards a convergent pattern of warning predators so that not every one has to be eaten, first before you imprint that idea in a vertebrate. Now this is a bug that you will never see out on the trail, but you will see evidence of it out on the trail. And that evidence is going to be in the form of a wood rat's nest. So if you're hiking around the trails and you see a wood rat's nest somewhere, then you've got a story for you right here in the western cone nose bug or the western kissing bug. And the reason why it's called a kissing bug is because it's a blood feeder, okay? And at least in other areas of the world, it's known to particularly try to feed around the face because it's apparently attracted to things that are coming out of our body in the face. But so why are they in the nests of wood rats? Because that's their normal host. That's who they like to feed on, are wood rats. Okay? But every once in a while they will blow in, like particularly the males who take flight from the nest, they'll come into homes and stuff like that. But also females, particularly if an area has been disrupted, if somebody's cleaned out a lot, then probably a lot of wood rats' nests got disturbed, and so all of a sudden these things are active. They're attracted to lights. They'll end up in people's houses. I've had multiple people call me about these and claim to have been bitten by them, which is a little bit scary because some people have done a lot of research up at UC Riverside where they've looked at the presence of something called Chagas disease in our kissing bugs. So it's a blood parasite. It's called Chagas disease. If you've ever traveled in Central and South America, you've possibly seen signs up for it warning you from something that looks kind of similar to this, bigger, a little bit more colorful because it's a different species, to be careful for them. Because when they bite you, they can transfer the Chagas disease to you. Well, we've got Chagas disease in Southern California. So why aren't there signs up everywhere warning us about these things flying into our home? And that's because the transmission of Chagas disease in Southern California is essentially zero. Okay? I think there's been a few cases reported in the southern part of Texas, in areas where there's really high levels of these particular critters. So the question is why? Well, if they've got it, and they every once in a while bite humans, why don't we have more reports of Chagas disease? And it boils down to a difference in behavior between the species that occur down in Central America, where Chagas disease is more popular, more common, okay, and here, where it's not very common at all. And you have to understand the transmission of Chagas disease. So if you were to get malaria, what does that mean? It means a mosquito flew up to you, it stuck its little proboscis into you, and blew its nose into you to release some enzymes to help suck your blood up and stuff like that. But it also released the malarial parasite into you in that process of blowing its nose. That's how you get malaria. When these guys bite you, they still inject some stuff into you, but that's not how the parasite gets into you. So they're biting you and they're feeding on your blood. And if they poop at the same time, that's where the parasite comes out. And so then the poop has to get into the wound, right, where they've been biting you, and that's how you get the transmission of this disease. Well, you'll be delighted to know that Southern California kissing bugs don't poop where they eat. Yes. So behaviorally, the point where transmission must happen is separated from the transmitting, bacteria. And so because of that, we've got low transmission here. Another related group, if you've ever been hiking around and you've seen some prickly pears and it looks like maybe some kids took some wet toilet paper and threw it in the prickly pear, you see this white stuff kind of all over it. That's caused by this scale insect. Somebody's kind of cleared a lot of the white papery stuff away from this. It's usually, you can't see it in this much detail. But it's a scale insect that's producing all this waxy stuff. And this scale insect is called cochineal. If I were to take one of these and crush it in my fingers, then my fingers would be covered in like the most fuchsia of fuchsias you've ever seen. Just like an incredibly bright red purple. And so you notice here, we have some sort of Native American here who is harvesting the cochineal, and you'll notice he's got red breeches. Okay? And that is because this cochineal has long been used as a dye for fabrics, pre-colonialism, used as a dye for fabrics. And when the conquistadors actually first arrived here, right, they were after gold, gold, gold. And then they saw these people with red pants. And red was the color of royalty back in Europe. Why? Because a red dye was very difficult to get, okay? And so they saw all this red, and they saw dollar signs or gold signs, okay? And there's two really good nonfiction books that are written on this discovery of the color red in North America and all the kind of industrial espionage that went on as people tried to hide this from one another and corner the color red market. I think one of them is called The Color Red or The Natural History of Red. If you Google it, you'll find it. Wonderful stories about this. Now, here's some of this is down in South America where the harvesting of this is more common. You can see the colors of the different yarns that they've dyed with this. But this is also in your grub, okay? This is a Yoplait, probably strawberry yogurt or something right there. And you see this word carmine there, okay? And carmine means crushed up cochineal bugs, okay? It's also called natural red number 4, so if you see that. And if you kind of remember, I can't remember what the date was on this. I feel like it was 1 or 2 years ago. There was a little bit of controversy at Starbucks about the strawberry frappuccinos not being vegan. And so I found this online. I thought that was funny. It includes fresh bugs because the strawberry coloration that they have in their frappuccinos is actually based on these carmine bugs.
Incidentally, we have red velvet cake back there.
I'm thinking that might be artificial red. So I'm going to talk a variety of times about galls, insect galls, because if you are a trail guide who does docent walks, then you got your stories associated with plants and galls. If you can start to find them, they're usually dependably there, so it's an interesting story that you can tell. And this is called the manzanita leaf aphid gall. So it's actually aphids that are inside these weird little blisters that you see on the edges of the leaves. And basically what happens here is that those aphids actually have something in their saliva that causes the plant to do this. It's almost like they're causing a little bit of a plant tumor of some kind. But this is a species-specific one that's just associated with manzanita. I have seen it in San Diego. I don't know if you guys have that within Elfin forest, but you might, something to look out for. Now here's like the insect that everybody in San Diego who walks around outside at any variety of times have to have run across. And these are the darkling beetles, the pinacate beetles, the stink beetles. They've got tons of different common names. Clown beetles is another one for them. And you can see one here in its characteristic threat posture, okay? Because it is threatening to you that I've got stinky stuff that comes out of my rear end. Don't mess with me, okay? Because they do have stink glands associated with their rear ends. And there's lots of different species of these, believe it or not. You've probably maybe thought you've always, it's the same one over and over again. But we've easily got a dozen species in San Diego County that all kind of look like this. Okay, there's like minor differences between them, but they all kind of look like this. And so this is a pretty good defense because predators see that. You can imagine if you're a possum or a skunk and you get into one of those one time and you get all that stink up into your mucous membranes and stuff like that, you're going to remember that threat posture. But there's one critter that's figured them out. They figured the game out that these pinacate beetles have, and that's the kangaroo rat. And what they will do is when they see them, doesn't matter if that rear end's up in the air or not, they run for them, grab them, flip them over, plant their rear ends in the ground, and then just eat them from the top down. And they leave behind the little stink gland parts that are at the bottom. And here's my call to you, walkers of trails in San Diego. Should you ever run across the bottom end of one of these critters, take a picture with your cell phone and email it to michaelmwall@sdnhm.org. So that I can show people in future presentations. Because I have yet to run across it yet.
This is the big, I've noticed this year, there's a
ton of them
on our property and in the park.
Yeah.
A lot.
It would be a really interesting study for somebody to do about the population cycles of pinacate beetles, because there was one year, probably about probably more around 7 years ago when I was out in Anza Borrego, and I had never seen so many of them. I mean, it was bonkers.
The other night I probably saw 50
Yeah,
in one area.
yeah. And I know there's got to be some sort of population cycles that they've got. There is an interesting myth associated with the pinacate beetle. It's a Pueblo myth that they were, it's a creation myth that they were charged with painting the night sky. It's in the, and that they were going along doing a good job painting the night sky when they spilled the paint and created the Milky Way, okay? And now they bow their head down in shame whenever they see us because they did such a lousy job painting the sky. But it's really, right, we know, they're not shamed, they're being really aggressive. Some other critters that you might run across if you're out on the trail, particularly in sandy areas, we see it all the time, that's good to know. In sandy areas, often they kind of like areas that are relatively protected, so if there's a little bit of an overhang or underneath a tree where there's a lot of protection, you'll see these inverted cones in the sand. And these are antlions. And at the bottom is this thing, okay? And you can't really tell in this photograph, but they're covered with lots of hairs coming off of their body. And those hairs they're buried in the sand. They're down there in the sand, and those hairs are stuck out in that sand. And those hairs are connected to little nerves inside their body. So the hairs are like extensions of their nerves that are going out into this sand. And they can actually feel ants walking along the sand, okay? And so there's this, I think we like to think that ants just go and fall down in there. But ants are like, they're not completely idiotic. Like if there's a change in their environment, they inspect it a little bit before they decide, do I want to go down or do I want to go around, kind of thing. Well, these guys can feel them approaching, and once they're up there inspecting to figure out what's going around, then they start using this weird big flat head that they have to flick sand up towards the ant. And it's not to like, oh, knock them unconscious and have them roll down the bottom to the bottom of the hill. It is to create an avalanche, because the walls of these cones are what scientists call built at the angle of repose. And what the angle of repose means that if any more sand is added to that wall, it's going to cascade. It's going to create an avalanche. So they are throwing sand up to create avalanches that will drag the ant down, and then they use these big honking mandibles to eat them all up. So that's the larval stage of ant lions. Yeah?
Well, there's all the sand coming down. How do they deal with all that sand?
I think they're effective at rooting around in sand. That's what it boils down to. I think they're good little diggers, is what it boils down to. Yeah. I would imagine it's a struggle. But that is the larval stage, but this is what the adults look like. And we don't typically see these because they fly at night and they're relatively short-lived. They're kind of like mating machines, okay? So they're not out for an extended period of time. If you were to do like a nighttime event here sometime and you set out like a black light or something like that to try to attract insects, at the right time of year you would get these, particularly if they're as common as you guys seem to find them out and about. All right, moving on. Well, these are one of the insects that you can kind of actively see during the daytime cruising around. They're not afraid to walk around during the day. They're velvet ants. This is one that is really white looking. It looks like it's got a white mohawk or something like that. But we also have some that are really red looking, okay? And these are all velvet ants, but they're not true ants, okay? They're actually wingless wasps. All right, so the females don't have wings. The males actually do have wings. Females don't have wings. And they're solitary. And remember, ants live in colonies, right? So they're solitary. And look at the size of the stinger. And again, red and black in nature means stop, okay? Because they will pack a punch. They are really high up on that sting pain index of critters that are out there on the East Coast. There's one common species that they call a cow killer because it's supposed to be so painful. What's their life cycle? What are they doing as they're cruising around on the trails that you're walking on? Is that they are looking for prey for their children to parasitize. So what they do is they crawl down into bees' nests, solitary bees, not like colonies of bees, but solitary bees, wasps, a lot of like sort of things that live underneath and develop underground. They crawl down there and they will